All right, okay. Let's look at this first question from Indices. The question is, if we have 4 raised power x is equals to 8 raised power 2x plus 1. What is going to be the value of x? That's the first question we're going to look at now. All right, so what I'm going to do, all right, let's look at this. Now, I told you guys before that the first thing you do here is to ensure, if you have something like this, A, B. Can you see this one on top? This one is called the power. Then this one in the downside is called the base. Take care of that. It's very, very important. So I already told you that this one below must be the same before you can move forward. If they are not the same thing, then the only thing you can do is to take the logarithm of both sides. That's the only thing that will work out. But the first thing for you to start taking logarithms, that may not be necessary. So what you need to do, you just have to therefore check, can they be the same? Because they are not the same. Now we have 4 here and we're having 8 here, so they are not actually the same thing. So can they be the same? Yes, they can. How? Because we can raise 2 to a power 2. The answer will be 4. That one is already done. This one is also the same thing as 4. Then we can raise 2 to power 3. The answer will be 8. You see? So we have introduced a new base for both of them, and we are still correct mathematically. Why? Because this one is 4, this one is 8. This is how you solve mathematics. So from here now, we still just introduce the power, which is 2x plus 1. So next, what am I going to do? We are going to open the bracket. We have 2 powers here. In this, if you have something like this, a raised power m and everything raised power n, the answer will become a raised power m times n. What you have to do is to multiply these 2 powers. You multiply the whole power to open this bracket. That's how you do that. So let's just apply that law of indices. So we're just going to do something like this. This power times this x. That is 2 times s. We have 2x. It's now equal to 2 raised power. This power times everything here. Both this 2x and this 1 is going to be affected by this power. So 3 times 2x, we are going to have 6x. Then 3 times 1, we are going to have 3. Next, since the 2 powers are done the same thing, you will just ignore the powers. You will ignore them. Then you will equate this. Okay, since the base, not the power, sorry about that. Since the base, the 2 bases are done the same thing. Look at this. This is the base, this is the base. So these bases are not the same. You will just ignore the base. Then you will equate the power. That's what I'm going to do now. So that we'll now be having 2x, that's the power of this side, is now equal to the power of this other side, which is equal to 6x plus 3. So the next thing, from simple equations, what do I call it? Simple equations. Now, from simple equations, what you have to do next is to collect like terms. Check, this one is having x. This one is having x. They are like. So you move them to one side. So you're going to have 2x. Now, if this 6, I already told you, if you have something without any sign, no plus, no minus, it means the number is a positive number. It's having imaginary plus. That is, if there's no sign with it. So if you move this one out to this side, that imaginary plus will change to minus. So we are going to have minus 6x is not equal to 3. You see, I may not write plus 3 now. Just write it as 3. It's still the same thing. See, there's nothing there to add to the 3. So you can something like make addition imaginary, just something like make it latent, hidden. So the next thing we're going to do will not be 2x minus 6x. That is 2 minus 6. That is minus 4 already, because 6 is bigger than 2. So you're going to have minus 4. Then x is equals to 3. Next thing, to make x the author of the film or the solid formula, we'll divide this by anything acting as a coefficient or attached to this x. Since this s is just ordinary s without any power greater than 1, so we have divided by minus 4, so that's 1 by minus 4. This we cancel this. Our x will now be equal to, okay, this minus cannot be at this denominator, so the minus will just come out. Then what will be left? 3/4. So this is the actual answer to that question. S is equal to minus 3/4. Now let's move to the next question. So the next question is, if we have 8 raised to power x plus 3 to be equal to 32 raised to power x minus 2, then divided by 2 raised to power minus x, what must be the value of these x? How do we do this? Okay, the first thing, break all the bases to be the same. Just break all the bases to be the same. All these bases, break all of them, ensure all of them will be the same thing at the end. So let's break. What can you raise to the power? And the answer will be 8, 32, and 2. It's 2. 2 will work out. How? Look at it. 2 raised to power 3. 2 raised to power 3 will give us 8. So that is already out of the way. X plus 3 equal to, now look at this. 2 raised to power 5 will give us 32. 2 raised to power 5 will give us 32. So 2 raised to power 5 is equal to 32. So the 2 is out of the way. You have x minus 2. Then over. Then 2 raised to power 1 will be the same thing as 2. So there's no need to change 2 again. The raised to power minus 1. Minus x. Sorry, minus x. You see, all the powers are now the same. So what are we going to do now? What are we going to do? So we just open this bracket. We're going to have 2 raised to power 2 times, okay, 3 times x. We're going to have 3x. 3 times 3, that is 9, plus 9 is not equal to, now let's go with this. 5 times x, that is 5x, 2 raised to power 5x. 5 times minus 2, that is minus 10. That's minus 10. Then over 2 raised to power minus x. So we are through with that. The next, we are now going to apply the rules of indices now. Remember, if you have something like this, if I have a raised to power m, then divided by, okay, let me use the normal division, something like this. If I have a raised to power m divided by a raised to power n, the answer will be a raised to power what? This minus this, which is the 2 power you just subtract them, minus n. You can also write it this way. A raised to power m divided by a raised to power n is still the same thing. We still give you this answer, a raised to power m minus n. So we are going to apply that rule now to resolve that stuff what you have here. So let's go. So if we decide to apply that rule, we are going to take this as our a, then this will be the second a. So we are going to have a raised to power m, this power will become the m, divided by a raised to power n, the answer will now be a raised to power m minus n, which is this 2 raised to power this minus this, something like this. It will now be this first 2, only one, you just take only 1 2. This 2 raised to power this power, which is 5x minus 10, then minus this power here, which is minus x. That's how it's going to be. But this will be too something like somehow too long. I have a very short way to do this. Look at it. Let me show you the short way to do that so that you see it. Look at how you should do something like this. If you have something like this in which these two bases are the same, take note of, let's say we have t raised to power minus 1 all over t raised to power 1, something like this. And you want to linearize this to be in just linear form. Look how to do it. You just pick one of the t's. You can just pick this t in the upper side. Just pick the t in the upper side, which is t raised to power minus 1. Since the two bases are the same, you will forget about this one, but you just move this power upward. And if you want to move this power across this division line, the power will change sign. For example, now this one is +1. If you cross this division line, it will change to -1. As it was -1 before, if we cross this one, then this division line will change to +1. I don't know if you understand it. Something like this. Let's say we have a raised power -1 all over b. Okay, it should not, the two bases should be the same. A raised power -2, something like this. If I want to generalize one, I'll just pick this a raised power -1. Then I will move this one to this side. Then if it crosses up, this power will the power will change sign. It was minus, but I will now change to +2. That's what I'm trying to say. That's another short way to do that. That one is very short, especially when you are doing the dimension analysis in physics. It will also help you very well. So let's apply that now. So we are now going to have 2 raised power 3x plus 9 is now equal to, just pick these two first, this one upward, 2 raised power, then pick this power 5x minus 10. Then you just move this one upward to go and meet this power. Then as it's going up, the sign will change. If it was positive, we change to negative. Negative, we change to positive. Check this one, it was negative before. We now change to plus x, positive. That is all. You are good to go now. So the next thing we are going to do now, without wasting time, we can just say 5 plus x, that is 6x. That one is okay. We can call that 6x. I call that 6x. But I will not do that. I will just, since the two bases are the same, this and this are the same, I'll just ignore it and equate the power. So that we now have 3x plus 9 is now equal to, the power of this one is 5x minus 10 plus x. So the next thing, let's move all the s to one side. Remember I told you you can do x plus 5s plus x, 6s, so already good to go. It's still correct. We're now going to have 3x. Then if this 5 crosses this line, we have minus 5x. If this plus s crosses this line, we have minus x. It's not equal to, this one is already minus 10. The minus will still be there. The minus will still be there, which is minus 10. Then if this plus 9 crosses this line to this side, we change to minus 9. So that will now be having 3 minus 5. That is minus 2. Minus 2 minus 1s. This one is 1s, but they will not write it if it's 1. They'll just write it as x. So we have 3 minus 5 minus 1. That will give us minus, what I'm going to have there. What I'm going to have there. Check what we are going to have in that place. 3 minus 5 minus 1. I think we're going to have minus, I think we're going to have, that is minus, okay, 3 minus 5, that is minus 2. Minus 5 minus 1, that is minus 3. That's minus 3 x is now equal to minus 19. Minus 19. So the next thing, divide that by minus 3. Divide the other side by minus 3 again. If you cancel this, s will now be equal to, if you cancel this, that is minus 9, that is 19 over 3. 19 over 3. Or you can just say how many times, I can go into 6, this is 6 times now. Are we? 6 times 3 is 18. That is 18 whole number 1 over 3. That is 6 whole number 1 over 3. Sorry about that. 3 can go to 19 6 times. 6 times. And it will be remainder 1. N over 3. So you can see have it this way. 6 whole number 1 over 3. 6 times 3. 18. 18 plus 1, that is 19 over 3. So this is the answer to this particular one. So let's go to the next one. So the next question is, if we have 5.5x plus 5 raised to power x is equals to 150, what will be x? Now in this case, we are having an operation sign here between two indices, not located in their powers, but between their bases. So if you want to solve something like this, we use substitution method. We use substitution method for this. Something like this. We use substitution method. And how do you use substitution method? You locate where you have equal indices. For example, now this is an index 6. It's an index 6. Just say let another unknown be equal to that indices. Just substitute something to that place. Try to see what you are having. For example, now let's say let y be equal to this 5x raised power x. You can do it this way. This is the methodology here. Anytime you see something like this, in which you have two indices being added together, for example, as you say a raised power x plus a raised power 3x plus 1, something like that. They are adding indices together. You use substitution method to solve the problem. Use substitution method to unravel the mystery. So we just first say let y, or let anything, let's say any alphabet or anything you can use if you want to represent something with another thing. And don't use number, don't use s. Since s is already here, don't go and be using s. Don't go and use number. You can use any other. You don't use o. O will look like 0. You can use a, b, c, d, e. Don't use f. F is a bad news. You can use h and so on. So I like using y. You can use z. So let that stuff be equal to this 5 raised power s. So anyway, see 5 raised power s, first of all put y. So we're going to have 5. We'll put y here. That's 5y plus y is equals to 150. So check what you're having. 5y plus y is equals to 150. Is that not a simple equation? So this is actually an initial equation, a form of a simple equation. But if you don't substitute something to that indices, you will not actually know what you are doing. So let's just solve for y now first. Then we'll now go back and solve for x. The first thing, 5y plus y. What is that? That will give us 6y. Then equal to 150. The next thing, divide side by 6. Divide side by 6. So I'll cancel this. Then y will now be equal to okay, let's go. 150 divided by 6. I think that's 25, right? That's 25. That is going to be 25. That's going to be 25. So y is equals to 25. Then what about x? What about x? We are looking for x, not y. And y, we said let y be equals to 5s. So that means y is representing 5s. So since this y is equal to 25 now from the question, that means you will now come back and say, okay, but we said y should represent 5x. So you come back again, any place you see y, you put just put 5s. So you're going to have, that is 5s per x is now equal to this 25 here. That's how you do this. 25. Because the word I'm using is a little bit small. So I hope the thing is clear. The first thing, we see two indices be added or subtracted from each other. What you just do, you just come and use substitution method. Just replace the indices with a single variable. Then the next thing, you discover that the question will change. That's how it is. The question will just change. If you can do the substitution, the thing will just change to either quadratic equation or simple equation, or maybe any other polynomial equation. So next, you just solve that quadratic equation or simple equation to get the substitute you use. After you got that substitute, you will go and substitute the value of the indices back to that substitute to get the value of x. Which is what we are doing now. Look at this one now. If I have 5 raised power x equals to 25, we can say make the two bases the same. Now 5 raised power x is now equal to 5. What is 5 raised to the power 1 to give us 25? 5 raised to the power 2. So this base, we just ignore them, equate the power. Then x will now be equal to what? Which is this 2. So actually, in this question, s is equals to 2. That's how it is done. The first thing, replace this 5 with an unknown because it's an indices. Because this is the methodology of solving this type of initial equation. But for just represent the indices with an unknown number, then the next thing, the question will just change to either quadratic equation or a simple equation. Then the next, solve out the quadratic equation or simple equation to get the unknown, which is this. Then the next thing, go back to this place, Replace this unknown with this indices, which actually this. So just remove this 5, this y, and replace it with this 5x. Then from here now, it will take you back to where we started from when we're doing this initial equation. So you just solve the other things, because it will now be very simple to just get the value of x. Let's have to do that. So let's get the last one now. We have 6 raised power x is equals to 36 raised power x plus 3. That's what I have in here. So what are we going to do now? What are we going to do? We are going to do something very lovely. Very, very lovely. And what is that? We have to make these two bases to be the same. How? 6 raised power x will now be equal to, what will 6 raised to give us 36? 6 raised power 2. Then raised power x plus 3. The next thing, 6 power x will now be equal to 6 power 2 times x, that is 2x. 2 times 3, that is 6. Ignore the base, then equate the power. We now have x is now equal to 2x plus 6. So to get the value of x, we just collect like things. This one move to this side. We have x, then minus 2x, because we change sign, equal to 6. Let's see, x minus 2, that is 1x minus 2, that's 1 minus 2, that minus 1x. We're going to have minus 1x is equals to 6. But this one, they don't used to put it, take note of that. So let me write it in a very nice way now. So I'll just put it as minus x. This one is same thing as minus 1x. Then it's equals to 6. The next thing, divide both sides by minus 1, so that this minus will go. Minus 1. This one cancel this. We're going to have minus x to be equal to minus 6. Actually, this is the answer to this problem. So this is how we roll in this place. So thank you.